All right, everyone. So today is part 2 of lesson 4.2. So we're still working with quadratic equations, but today the focus is going to be on finding the roots by using the quadratic formula. So quadratic formula for any quadratic that is in the following format. So it's got to be in ax squared plus bx plus c equal to 0 form. There's your quadratic formula. So it looks pretty scary, but all the a's, b's, and c's are coming from the coefficient on your x squared term, the coefficient on your x term, and then your constant or your c value. So x is going to be equal to, the roots will be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. So it's really important. I want to point out this negative b that starts the quadratic formula. What that means is you're starting off with the opposite sign of b. So if your b value, let's say for instance, is positive 3, you would start with a negative 3 and vice versa. So the portion of the quadratic formula that goes underneath the square root, that is called the discriminant of a quadratic. And that discriminant value allows us to determine what type and how many roots our quadratic is going to have. Because taking a square root of a positive number will give us different information than the square root of a negative number. So here's our 3 possibilities for types of roots. First, if that discriminant b squared minus 4 times a times c, if that number ends up being greater than 0, you're going to have 2 real roots, meaning that this quadratic would cross the x-axis twice. If your quadratic discriminant value ends up being equal to 0, what that means is there's going to be 1 real root, because plus or minus the square root of 0 is going to give you 0 both times. So you'll only have 1 real root. And then lastly, if that discriminant is less than 0, so you get a negative value underneath your square root, you're going to have 2 imaginary roots from that. So we're going to go through 3 examples, and we're going to calculate the discriminant of each quadratic, and then we're going to be using them to describe the nature of the roots. So how many roots do we have, and what kind of roots are they? Are they real or imaginary? So our first quadratic, we've got negative 10x squared plus 7x plus 9 equal to 0. This is already in the correct format that we want it to be in order to easily identify our a, b, and c. So the a value is negative 10, b is positive 7, and c is 9. So from that, we're going to plug in, and all we want to find is the discriminant. So just the b squared minus 4 times a times c portion. So that's how it would look filled in: 7 squared minus 4 times negative 10 times 9. That would give us a discriminant value of positive 409. So since we got a positive value greater than 0, what that means is we are going to have 2 real roots for this quadratic. Let's look at problem B. We're starting with x squared plus 21 minus 8x equals 0. So this one looks like it's okay, maybe at first glance, but it is out of order. We want to make sure our x squared term is first, the x term is in the middle, then your constant equal to 0. So here's how it would look rearranged. The a value would be 1, which is that invisible 1 that's on your x squared term. B is negative 8, and c is 21. Filling in b squared minus 4 times a times c, we would get negative 8, that quantity squared, minus 4 times 1 times 21. So for this part right here, when you guys type that into your calculators, make sure that your parentheses are around the -8 and the squared is on the outside, because otherwise your calculator will not find the value that you want it to. It'll take the opposite sign instead. So make sure those parentheses are around the -8, squared on the outside. So calculating our discriminant value, we get -20. So our discriminant was a negative number. What that means is we are going to have two imaginary roots. And the reason for that is when we take the square root of that negative, that's where your imaginary numbers come into play. All right, let's look at C. We've got 60x plus 5x squared equal to -180. So there's a couple things wrong. First, we've got our terms are out of order from the order we want them to be in. And secondly, I don't have equal to 0. And we need to have our quadratic equal to 0 before using that quadratic formula. So what we're going to do first is we're going to add the 180 on both sides to move it over to be with the rest of the terms on the left. And then I'm just going to rearrange those terms on the left-hand side so that they're in the correct order. And now I get 5x squared plus 60x plus 180 equal to 0. So there's our A, B, and C. Filling those in to find the discriminant, we get 0 as the discriminant value. So when we have a discriminant value of 0, this is when we are only going to have one real root, because plus or minus the square root of 0 is going to give you 0 both times. So you'll only have one real root for that quadratic. All right, next we are going to use the quadratic formula all the way to the end to figure out what the roots are, and we're going to write them in exact form. So first I'm checking to make sure my quadratic is in correct format, and it's a little bit out of order. So I'm just going to rearrange it so that my x squared is first, x is in the middle, then my constant equal to 0. Here's the A, B, and C values. I'm going to take A, B, and C, so my 3, my 6, and my -7, and I'm plugging everything in for my A's, B's, and C's into the quadratic formula. So here's what it would look like. Starting off our formula, we've got a -6. So that's coming into play from the opposite of B. Our B value was +6, so opposite of B is -6. Then we've got our plus or minus, then it's a big square root, and underneath there, you're going to find the same calculation as your discriminant. So we've got our B squared -4 times the A value times the C value. And then this is all over 2 times the A value. And remember, those A's, B's, and C's are coming from the list that we wrote out here. Now, sometimes I get a question of where's this 4 coming from? Where's this 2 coming from? And the super smart person who came up with the quadratic formula recognized that the 4 and the 2 need to be a part of the quadratic formula in order for it to work. So you're always going to have a 4 here and a 2 here. All right, let's simplify. The next two things you're going to calculate is just the discriminant value. So the number that goes under the square root. Do not take the square root of it. Just find out that number underneath. And then we're also going to simplify the denominator of our fraction. So here's what we get. So 6 squared minus 4 times 3 times -7 gives us 120 underneath our square root. And then the 2 times 3 in the denominator just becomes 6. Next, I'm going to see if I can break down the square root of 120. And I can, because the perfect square 4 divides 120 into the square root of 4 times the square root of 30. So simplifying, we would get 2 square roots of 30. And I'm just going to replace the square root of 120 in my formula with 2 square roots of 30. The last thing you're going to do is to check these 3 numbers. And what we're checking for is a common factor. So since all 3 of those numbers are divisible by 2, I'm going to divide each of them by 2 to simplify to my final answer. So my final answer in exact simplified form, my two roots, x is equal to -3 plus or minus the square root of 30, and that's all divided by 3. And you're going to leave it in that format. That's as simplified as we can go. All right, here's our next one. This one is not in the correct order. We need to move our x squared to the other side. So now it becomes x squared minus 5x plus 22 equal to 0. Here's my a, b, and c. And let's fill them all in to the quadratic formula. So again, we're starting with the opposite of b. Our b value this time was -5. So that means we're going to start with +5. 5 plus or minus the square root of, and then we've got our b squared minus 4 times a times c underneath, all over 2 times your a value. We're going to find just those two values, the number under the square root, and also simplify the denominator. So here's what we would get. 5 plus or minus the square root of -63. And then this is all divided by 2. I can simplify the square root of -63. I know I'm going to get imaginary because it's a negative number that we're taking the square root of. But 63 also breaks down into the square root of 9 times the square root of 7. So my final simplified answer for that would be 3i times the square root of 7. So I'm going to replace that square root of -63 with the 3i square roots of 7. Here it is. Checking these three numbers to see if there are any common factors. There aren't between 5, 3, and 2. So this is my final answer written in exact form. All right, here's the last one. Not in the correct format. I don't have equal to 0. I need to move my 7x over and write the left-hand side in the correct order, giving me 2x squared minus 7x minus 3 equal to 0. Here's the a, b, and c. Filling everything into the quadratic formula. There it is. Finding the value underneath the root and simplifying the denominator. Here's what we get. We can't break down the square root of 73, so there's no other way that we can simplify this. So that is your final answer in exact form. All right, that is it on using the quadratic formula to find the roots of a quadratic. So after today, you guys should be able to complete all of your 4.2 homework. So I'll be back tomorrow to answer any questions that you may have, but hope you guys have a great rest of your day, and I will see you tomorrow.